Hello, my name is Casey Goyette, and my project was a variable angle 3D printer extruder. So the challenge I worked on was creating a variable angle 3D printer extruder to create 3D prints at angles other than perpendicular to the build plate. This is to allow for 3D printers to print complex features with little or no support material, as well as print features that would be impossible to print with current fused deposition modeling, also known as FDM, 3D printing technologies. I decided to undertake this project because I've been fascinated with 3D printing for a long time, and having attended a vocational technical high school, I've had the opportunity to work directly with 3D printers for many years. Because of my fascination with 3D printing, I wanted to create something to help improve the 3D printing process, and I felt this project was the way to do so. This project is important because current FDM 3D printing processes limit the features that can be accurately printed without support, or that can even be printed at all. This is a problem because support material often leaves imperfections and can be difficult to remove, which is generally unacceptable in industry where accuracy and tight tolerances are essential. This project would expand the types of existing components that printers can create parts around, as well as the complexity of features that can be printed in the first place. For this project, most of my time was spent designing and building a prototype of the extruder. So as you can see here on the left, the first step was to create a model of the extruder mechanism in SolidWorks. And at the same time as I was creating this model, I had to select off-the-shelf components such as screws and bearings to help assemble the final model with. Once the model was finished, I 3D printed all of the custom components I designed and assembled them using the off-the-shelf components. I then did some basic electronics work here, which you can see using an Arduino microcontroller and stepper motor drivers, and some basic software work to make it move. By far the biggest obstacle I faced during this project was designing and assembling the individual parts of the prototype, as everything didn't fit together on the first try and had to be redesigned and re-3D printed several times. So for physical products, I was able to build a functioning prototype, and by building this physical model, I was able to prove that the concept could work with some software work beyond the basic movement programs I created. During this project, I learned that there's not been much previous investigation in the area of making variable angle 3D printer extruders. However, through my project, I was able to prove that a variable angle 3D printer extruder is possible and can be built. Personally, during this project, I also learned that I'm able to take a problem with set constraints and deadlines and create a viable solution to that problem. I also learned that communication is extremely important when completing any kind of project, that any ideas you might have in your head need to be communicated clearly and effectively to allow others to envision what you have in mind. Lastly, I learned that I enjoy innovating within the field of 3D printing and would like to innovate further within it. Based on everything I gained from this project, I think that the next steps are to get the prototype to function in a way that can actually create 3D prints, such as developing software to control flow rate of filament and control the angle. I want to attach the extruder to a gantry to create full 3D prints, and I'd like to condense the design to fit it within a smaller footprint.